When you have strong storms, that's really when you stir the ocean, when you mix things up, where things happen. So storms are very important. It's just up until recently, we had a hard time getting good measurements from storms.
For obvious reasons, the surface of the ocean is a dangerous place for equipment to be. It gets banged around by large waves, and unfortunately, that's also where some of the most interesting and important processes are taking place. The interaction of the atmosphere and the ocean is where gases are being transferred. It's where stress from the wind is being transferred into the ocean. It's where nutrients from the seawater are being utilized by phytoplankton that grow on the sea ice. But the sea ice has a nasty habit of grabbing hold of instruments and ripping them off your moorings or dragging the entire mooring away.
At every station we go to, we have to untie all our equipment, use it at a station. As soon as we're underway again, we have to tie it all back down.
When we go early in the season to capture some spring events maybe, or we go on land fast ice off of Faro in February or something, well, then you run into 20, 30 below plus wind chill, and then it gets really cumbersome to manipulate gear. And then we put our samples in coolers to keep them warm so that they don't freeze right away.
It's basically the track for all storms and low pressure systems that travel across the North Atlantic. One thing that the Arctic is changing, which is interesting to us as oceanographers, is that since we have less sea ice, even in the shoulder season, spring and autumn, we have more input of wind and energy into the ocean. So we have now an ocean that starts to look more like an ocean in the lower 48s. So you have bigger waves, more energy into the ocean, which helps the ocean to mix, and it changes the whole dynamics of the Arctic. So there's big changes going on just by having less ice and more energy from the wind directly into the ocean.
We're expecting in the Arctic to see more precipitation across the whole Arctic. So that's going to mean that rivers swell up, we get more river outflow into the Arctic seas. Additionally, we're getting more wave action because we've heard that sea ice is retreating. That opens up a lot bigger stretches of open water where winds can pick up, so we get more battering of winds against the coast and more coastal erosion. Both of those things, the higher river inputs and the coastal erosion, mean that we're getting more terrestrial, land-based carbon that's going into the marine environment. Right now, we don't really know what that means. What's it going to mean for the marine organisms that are living there? They might not be able to use that land-based carbon as good as they can use the carbon that's created in their own marine environment. So I'm hoping that we can see what this new input of terrestrial matter is going to mean for marine organisms. And on top of that, how is that going to affect the higher levels of that Arctic food web? Who's going to benefit? Who's going to suffer? Are polar bears, our walrus, our whales going to do okay if these lower levels of the food web are affected?